Welcome students to online classes of mathematics for class 9. In this video we are going to study chapter number 8, which is Quadrilaterals of NCERT textbook, and we will be covering this exercise 8.2. Since we have already covered the first three questions, that is question 1, 2, 3 of this exercise in the previous session, so today we are going to look at the question number 4 to question number 7. Okay, this is session number 5 for this particular chapter. Myself Deepak Kodam, GD Mathematics in Kendriya Vidyalaya Sangathan. So let's start with today's class. So we're going to start now today the chapter 8 quadrilateral. Since we have already done the first three questions of this exercise in the previous session, so today we are going to start with the question number 4. So the fourth question number 4 is ABCD is a trapezium in which AB is parallel to DC and BD is a diagonal. So we have this trapezium in which AB is parallel to DC and BD is diagonal, and BD is a diagonal, and E is the midpoint of AD. So we have this E, which is the midpoint of AD. A line is drawn through E, which is parallel to AB. So we have drawn this line through E, which is again parallel to AB and intersecting BC at point F. We have to show that F is the midpoint of BC. Okay, so let's start its answer. It's answer number 4. First we will mention the given portion. Given here is a trapezium ABCD. We are given a trapezium ABCD in which AB is parallel to DC and BD is a diagonal. BD is a diagonal and E is the midpoint of AD. Okay, we have E, which is the midpoint of AD, and there is a line passing through E and parallel to AB, intersects BC at F. Okay, we have to prove that. To prove here is that we have to prove that F is the midpoint of BC. Okay, to prove is F is the midpoint of BC. Okay, now let's start this proof. Proof here is we are going to start first with the triangle. Let's name the point where this diagonal BD is intersecting EF as at point G. Okay, so we have point ABCD is a trapezium. E and F are the point on the line AD and BC, and G is the point where the diagonal and this line through E is intersecting each other. Okay, so now first we are going to start with the triangle BAD. So start in triangle BAD. We have, since it already given that E is the midpoint of AD, so as we have E is the midpoint of AD. This is given in the question. Therefore, by applying the converse of midpoint theorem, that is theorem 8.10. okay, therefore we will have that this side EG is parallel to AB. Okay, EG is parallel to AB. This is by, since this EF is already parallel to AB. EF is parallel to AB. Okay, reason for this EF is parallel to AB, we have just taken the portion of EF. That means EG is also parallel to AB. Therefore, or you can say therefore, by the converse of midpoint theorem, Converse of the midpoint says if a line is drawn through the midpoint of one side parallel to the second side, and that will bisect the third side. Okay, that's what the converse of the midpoint theorem says. So we have a line through E which is parallel to AB, so it will definitely bisect the third side. Therefore, by midpoint theorem, okay, we have G is the midpoint of G is the midpoint of diagonal BD. Okay, so we got that in this triangle by applying the converse of midpoint theorem. We got that G is the midpoint of the diagonal BD. Now moving ahead, now in triangle, now in the second triangle, this one is triangle BCD. In triangle BCD, we have here that G is the midpoint of BD. This is proved above. Okay, again, therefore this line segment GF will be parallel to DC. Okay, therefore GF, not E, GF will be parallel to DC, because DC is already parallel to AB and AB is parallel to EF. So these are the portion of EF, so they will also be parallel. Okay, GF is a portion of GF, so EF is already parallel to DC. So we can say that F is the midpoint of the side, F is the midpoint of side BC. Okay, therefore by converse of midpoint theorem, therefore by the converse of midpoint theorem, we can say that F is the midpoint of BC. Okay, and that's what we were asked to prove here. So simply what we did is, first we taken this triangle and applying the converse of midpoint theorem. Since this E is the midpoint of DA, so this G will be the midpoint of BD. Okay, then in the second triangle, this one, since this G, there is a line passing through G cutting the it's the this side, so this F has to be midpoint of BC. Okay, that's the proof of the question number 4. Now moving to the question number 5. In this question we have, in a parallelogram ABCD, E and F are the midpoint of side AB and CD respectively. Show that the line segment AF and EC trisect each other. So we have this parallelogram ABCD in which we have midpoint of side DC is F and midpoint of side AB is E. Okay, so we have joined AF and EC, so we have to prove that if this is bisecting the diagonal BD in 3 equal parts. Okay, trisect means 3 equal parts, that is DP is equals to PQ is equals to QB. Okay, that's what we have to prove here. So let's start the answer number 5. First we will mention the given things. Given is a parallelogram ABCD, a parallelogram ABCD in which E and F are the midpoints of the sides AB and CD respectively, AB and CD respectively. Okay, we have to prove here is that AF and EC trisects the diagonal BD, trisects the diagonal BD. Trisect means dividing into three equal parts. Tri stand for three, sect means sections, okay, three equal sections. So we have to prove that AF and EC are dividing that BD into three equal parts. So let's start its proof. Here we have that ABCD is a parallelogram, okay, so we have, right, in parallelogram ABCD, in parallelogram ABCD, we have this side AB is equals to CD, okay, also AB is parallel to CD and AB is parallel to CD because they are the opposite sides of the parallelogram. So inside bracket you can write opposite sides of parallelogram AB CD. That's why they are equal and parallel, okay. Now since E is the midpoint of, we are given that E is the midpoint of AB, therefore this line segment AE will be equals to the half of AB, okay. This is, let's name it equation number 1. Then we have, since F is the midpoint of CD, therefore this FC will be equals to, or you can say CF is equals to half of CD, okay. This CF will be equals to half of the complete length of the side CD, okay. And we already have that AB is equals to CD, so we can replace this CD by, or we can write CF equals to half of AB. Reason for this one is because AB is equals to CD as given in the question, that ABCD is a parallelogram, okay. So what you notice from here is that this AE is equals to half of ABC, sorry, half of AB, and CF is also equals to half of AB. Let's name it equation number 2, okay. Then from equation 1 and 2 we get, from equation 1 and 2 we get, what we get is that AE is equals to CF, AE is equals to CF, okay. So that means these two portion AE is equals to CF here, okay. And since they are also the part of the parallel line AB and CD, so they will also be parallel, okay. And AE will be parallel to CF because AB is parallel to CF, sorry, CD, okay. And this AE and CF are the part of AB and CD respectively, so therefore these two are also parallel. So what we got here is that we got one pair of opposite side equal and parallel, therefore we can say that the quadrilateral AECF is a parallelogram, okay. Thus quadrilateral AECF is a parallelogram, okay. So we have proved that AECF is a parallelogram because its one pair of opposite side is equal and parallel, okay. Because in bracket write one pair of opposite side is equal and parallel, that's why this AECF is a parallelogram, okay. Because we got one pair of opposite side equal and parallel, and from theorem 8.8 we know that if in a quadrilateral one pair of opposite side is equal and parallel, then it will be a parallelogram, okay. And since this is a parallelogram, so this will implies that this implies the remaining other two sides, that is this AF and CE, will also be parallel because they are now the side of a parallelogram. So we can write, therefore EC is parallel to AF, okay. And this implies that EQ is parallel to AP. Again we are repeating, shortening this side, this Okay, first these two complete sides are parallel, therefore their portion EQ and AP will be parallel, and similarly their portion QC or FP will also be parallel. Okay, so EQ will parallel to AC and the other part QC is parallel to PF. Okay, because both are the part of the parallel lines EC and AF, so they will also be parallel. Okay, now come to the triangle BAP. Now we come to the triangle BAP is this one. In this triangle you can see that if these two sides are parallel and E is the midpoint, so Q will also be the midpoint of the side PB. Okay, so we'll write in triangle BPA, in triangle BPA we have E is the midpoint of PA, therefore what we get is that EQ is parallel to AP. Okay, this is by converse of midpoint theorem. Converse of midpoint theorem. Okay, that's why these two are also parallel, and this implies BQ is equals to PQ. Since these two are seen in the diagram, since these are parallel, so Q is the midpoint, so this BQ and PQ will be equal. That means they are bisecting each other. This point is bisecting the side PB. Okay, in similar way we can prove that similarly in triangle, in another triangle that is CQD, we have DP equals to QP. Okay, that means this DP and QP are also equal, and so that means this QP is equals to PQ and DP is also equals to PQ. That means all three are equal. Okay, so let's name it equation number 3 here and 4. Let's name it 3 and this one is 4. So we can write now equation from 3 and 4 we get from equation 3 and equation 4 we get that all three are equal. That is BQ is equals to QP is equals to PD. Hence AF and CE trisects diagonal BD, and that's what we were asked to prove here. We have to prove that AF and CE are trisecting diagonal BD. We have proved that all three parts of the diagonal are equal, hence the two lines AF and CF are trisecting the diagonal BD. Okay, I hope you understood it. If you can watch it again to understand it better. Okay, now let's move to next question. Question number 6 is show that the line segment joining the midpoint of the opposite side of a quadrilateral bisect each other. That means we have a quadrilateral in which the midpoint of all four sides are joined together, and we have to show that they are bisecting each other. Okay, so first let's start the answer number 6. We'll write the given portion. Given here is a quadrilateral ABCD. We have given that name, a quadrilateral ABCD, in which P, Q, R and S are the midpoints of sides AB, BC, CD and DA. This is what we are given to us. Okay, also we have joined both the diagonal, that means joined and PR and SQ are intersecting intersecting at point O. Okay, we have to prove here. To prove here is we have to prove that the diagonal, this PR and SQ are bisecting each other, which means the distance of OP is equals to OR and OS, or you can say SO, is equals to OQ. Okay, OP is equals to OR and OS equals to OQ. That's what we have to prove, that both the diagonals are bisecting each other. Okay, let's start its proof. Proof simply is, what we're going to do is, we will prove that this PQRS is a parallelogram, and we know that in a parallelogram diagonals bisect each other. So just by proving that PQR is a parallelogram, we will get this required result that both the diagonals are bisecting each other. And we'll prove that this PQR is a parallelogram by using midpoint theorem. Okay, so let's start first with the triangle, this ABC. Okay, right, in triangle ABC we have, so okay, in this triangle ABC we have P is the midpoint of AB and Q is the midpoint of BC. We have P is the midpoint of AB and Q is the midpoint of BC. Okay, therefore by using a midpoint theorem we can say that this PQ is parallel to ABC and PQ is equals to half of AC. This is by midpoint theorem. MPT means midpoint theorem. Okay, let's name it equation number 1. In similar way, now in triangle, now we'll take this second triangle which is ADC. In triangle ADC we have, what we have is that R is the midpoint of DC and S is the midpoint of DA. R is the midpoint of CD and S is the midpoint of DA. Therefore this side SR is parallel to AC. Therefore SR is parallel to AC and SR is half of AC. Let's name it equation number 2, and this is again by midpoint theorem. Okay, so from equation 1 and equation 2, from equation 1 and equation 2 we get, what we get here from here is that this PQ is equals to AC and similarly this SR is equals to AC. That means both are equals to AC, both are parallel to AC. That means they are also parallel. Okay, so we get PQ is parallel to SR. In similar way, this PQ is equals to half of ABC, half of AC. Similarly, this SR is equals to half of AC. That means both are also equal because they are equal to the same thing. That means PQ is equals to SR, and this implies PQRS is a parallelogram. Okay, this is by the theorem 8.8, which says if in a quadrilateral one pair of opposite side is equal and parallel, then it is a parallelogram. Okay, so we will write, because one pair of opposite side is equal and parallel, That's why PQR is a parallel, since we got one pair of opposite side is equal and parallel. So right, since PQRS is a parallelogram, therefore we know that the diagonal of a parallelogram bisect each other. That means what we have to prove here is that this OP is equals to OR, therefore OP will be equals to OR and SO is equals to OQ. Okay, because the diagonals of a parallelogram bisect each other. Diagonals of a parallelogram bisect each other. Okay, so we have proved that the diagonals are bisecting each other. That's what we have to prove, that the opposite side of a quadrilateral bisect each other. So what we got is, by joining the midpoint of the opposite side, we got the two lines which are bisecting each other. OP is equals to OR and SO is equals to OQ. Okay, so that's the answer of question number 6 of exercise 8.2. Now coming to the question number 7. Question number 7 is, ABC is a right angle triangle at C. So that means this triangle ABC is right angle triangle which is right angle at point C. Okay, a line through midpoint M. So we have midpoint M of hypotenuse AB. So we have this side AB in which M is the midpoint of AB, and a line through M parallel to BC intersect AC at D. So line through M, which is this one, this is parallel to BC and meeting AC at point D. We have to show three things. First is that D is the midpoint of AC. Second, MD is perpendicular to AC, and CM is equals to M is equals to half of AB. Okay, so let's start its answer. Number 7. First we'll mention the given portion. Given here is a right angle triangle ABC, a right triangle ABC right angled at angle C. Okay, then we have M is the midpoint of AB. M is the midpoint of AB, and a line through M parallel to BC intersects AC at D. Intersects AC at D. Okay, this is what given to us. We have a right angle triangle ABC, which is right angle at C, and M is the midpoint of AB, and the line through M parallel to BC intersect AC at point D. Okay, we have to prove three things here, so let's try to prove. First thing that we have to prove is that D is the midpoint of AC. That D is the midpoint of AC. This is the first thing. Second, we have to prove that MD is perpendicular on AC, and the last we have to prove that CM is equals to MA is equals to half of AB. Okay, this is very simple. We prove each one by one. So let's start proof of part 1. What we have here is we have to prove D is the midpoint of A. So we'll simply use the midpoint theorem as a converse of midpoint theorem. We'll write, in triangle ABC, we have, what we have is that since M is the midpoint of AB, M is the midpoint of AB, this is given in the question itself, and the line through M, which is MD, is parallel to BC. This is also given in the question. Okay, so by the midpoint theorem, so if we have a midpoint of one line and a midpoint of one side of a triangle, and there is a line passing through that point, parallel to the second side will bisect the third side. Okay, therefore D is the midpoint of AC. Therefore D is the midpoint of AC. This is by converse of midpoint theorem. Okay, converse of midpoint theorem says if a line segment joining the midpoint of one side parallel to the second side will bisect the third side. So we have line segment passing through M, which is the midpoint of AB, and MD is parallel to BC, so that definitely D will be the midpoint of the third side AC. Okay, so we got the proof of the part 1 that D is the midpoint of AC. Now come to the second part, that MD is perpendicular on AC. Okay, let's come to the second part. Here we have to prove that MD is equals to MD is parallel to AC. Okay, but here we have that MD is parallel to BC. So we have, since MD is parallel to BC, therefore we have two angle, that is angle ADM will be equals to angle ACB, and both will be equals to, you can see here they have triangle ADM is this one, and triangle ACB is this one. Both will be equal because these two are the parallel lines, and this AC will work as the transversal. So these two angle are the corresponding angle. Okay, that's why they are equal. Reason for this one is corresponding angles, and we know the corresponding angles are equal. That's why these two angles are equal. Since we already have angle C is 90 degree, so what we can write, or angle ADM is equals to 90 degree, since angle ACB is equals to 90 degree. Okay, that's why this angle will also be of 90 degree. Okay, so we got that measure of this angle is also 90 degree. Now these two angles are forming linear pair. Okay, so let's, okay, since we have proved that this is making a 90 degree angle here, so we can directly say that MD is perpendicular on AC. Okay, so we'll write that hence MD is perpendicular on AC, since angle ADM is of 90 degree. Okay, that's a proof of the second part. Now let's come to the third and the last part of the question, which is we have to prove that CM is equals to MA is equals to half of AB. Here we have to prove that CM is equals to MA is equals to half of AB. Okay, for that we'll start with the two triangle. In triangle AMD and triangle CMD, we have, let's locate the triangle. Triangle AMD is this one and CMD is this one. So we are dealing with, let's say, these two triangles. Okay, in this triangle what we have is AD equals to CD, AD is equals to CD, since D is the midpoint of AC. Okay, D is midpoint of AC. Okay, then we have the angle ADM and CDM equals to 90 degree each. ADM will be equals to angle CDM. Okay, each of 90 degree, because we have proved that this MD is perpendicular on AC. Okay, then we have MD is equals to MD because they are common. Therefore triangle AMD is congruent to triangle CMD, and this is by side angle side congruence rule, by side angle side congruence rule. Okay, now since these two triangles are congruent, so their corresponding part, so this implies this side MA will be equals to MC. This is by CPCT. Corresponding parts of congruent triangle are equal. Okay, and also MA is half of the side AB, so we can write MA is equals to half of AB. Okay, since M is the midpoint of AB, right? M is midpoint of AB. Okay, so finally what we got is, hence CM is equals to MA is equals to half of AB. Okay, because we have proved that MA is equals to MC, MA is equals to half of AB, so this CM or MC is equals to MA is equals to half of AB, and that's what we have to prove in the part second of question number 3. Okay, I hope you understood this now. So with this we have completed all the questions of exercise 8.2. I hope you understood all the questions. Okay, what you have to do is practice these questions multiple times, only then you will be able to understand this better. Okay, otherwise this question will trick you. So that's all for now. Thanks for joining here everyone. Thank you.